Okay, today we're talking about rational exponents. So what does it mean to have a fraction, a rational number in the exponents? And the key idea here is that you have some number to the m over n. Well, that is just going to equal either one of two things. You could write it as the nth root of a to the m on the inside of the root, or you could write the nth root of a and then put parentheses around that and take the entire thing to the nth power. And you'll see why later on this notation can actually be very useful for us as we simplify. So just to keep in mind, the n is the index, right? The index, the type of root, right? And the m is just your exponent. The m is just the exponent. Okay, so knowing that, just some quick examples. X to the 1/2. So again, the 2 is the index, the type of root, so that's just a square root of x to the first, square root of x. 32 to the 1/5. Again, the 5 is the index, the type of root, so it's the fifth root of 32. And I can write 32 as 2 to the 5th. So the fifth root of 2 to the 5th is just 2. And finally, 729 to the 1/6. So again, that's the type of root. That's the sixth root of 729. And I can write 729 as 3 to the 6th. So the sixth root would just be 3. All right, now that we have those quick examples out of the way, let's tackle some other ones. So number one, let's go ahead and let's simplify. Simplify. Let's start off with letter A. Let's do 8 to the 1/2 times 2 to the 1/2. 8 to the 1/2 times 2 to the 1/2. So we have two options here. We can change to radical form. Change to radical form. Or number two, we can rewrite so they have the same base. Rewrite so they have the same base. And for method 2, why do we care about that? Well, if I have the same base, remember, if I have like 2 to the 3rd times 2 to the 5th, if you have the same base here, you can just add these numbers up and you get 2 to the 8th. So if I can rewrite these so they have the same base like 2, then I can just add those exponents. So first, method 1, if I change these to radical form, this is going to be the square root of 8 times the square root of 2. That's the square root of 8 times 2. That's the square root of 16. So that equals 4. Now, if I rewrite it so they have the same base, I want to rewrite 8 as 2 to some power. So I'm going to rewrite 8 as 2 to the 3rd. 2 to the 3rd to the 1/2 times 2 to the 1/2. Notice I have not changed anything. 2 to the 3rd is 8. 2 to the 3rd is 8. But now I have a power to a power. Remember, power to a power rule, you just multiply these. So this is 2 to the 3 times 1/2, which is 3 over 1 times 1 over 2. So 3 halves. 2 to the 3 halves times 2 to the 1/2. 2 to the 3 halves times 2 to the 1/2. Now I can add these up. I can add those exponents, so I get 2 to the 3 halves plus 1/2. That's 2 to the 4 halves, which is 2 squared, which is 4. So these are working the same way. Let's try another one. Same methods. Let's call this letter B. Let's simplify. Let's do 125 to the 1/3 times 5 to the 1/3. Okay, 125 to the 1/3 times 5 to the 1/3. So first, let's try the first method. Let's change it to radical form. So that's the cube root of 125 times the cube root of 5. I multiply these together. I get the cube root of 125 times 5. That's 500, and 25 times 5 is 125. Add up 500 and 125, I get 625. And so I have the cube root of 625. So let's say I don't know what that is. Let's try method 2. Maybe we can get something out of method 2. So 125 to the 1/3. I want to rewrite these so they have the same base, method 2. So let's rewrite this to have a base of 5. Well, I know 5 to the 3rd is 125. So I'm going to rewrite this as 5 to the 3rd power. That's 5 times 5 times 5. That's 125 to the 1/3 times 5 to the 1/3. Maybe this method will be easier for us. So now we take a power to a power, so we get 5 to the 3/3 times 5 to the 1/3. But of course, 3 over 3 is just 1. 1 times 5 to the 1/3. And now I can just add these up. So actually, it's probably easier just to add it like this. So 3 plus 1 equals 5 to the 4/3. 5 to the 4/3. All right, and we can just leave it like that.